Welcome back to our new PySpark series, Module 1. So, he is the Spider Man. He will ask questions related to Apache Spark Foundation, and we are going to answer all of his questions. He is like our student for this Module 1. Okay, so let's begin. So, our first question is, what are the problems which are related to Hadoop MapReduce? Okay, what is the issues with Hadoop MapReduce? So first let's see what is Hadoop MapReduce. So it is nothing but a framework used to process big data in distributed way. Okay, it's a framework used to process large data sets in distributed way. Now what is distributed way? We have already seen a Redshift cluster. So one parent node will be there and many child nodes will be there. So whenever we want to query something, it will split our query in smaller tasks. Task will be assigned to child nodes, and those tasks will run parallelly, right? Simultaneously, they will perform the task. Finally, it will combine the result and give us the final output. This is called distributed processing. Okay, so it makes our data processing faster. Now we know what is Hadoop MapReduce and what is distributed processing. Now Spider-Man is asking one question. If large data sets and all can be processed with Hadoop, then why the heck are we even learning Spark? Okay, if everything can be done using MapReduce, then why we need to learn Spark? So these are the reasons. First is slow processing speed. So actually Hadoop MapReduce uses disk for data processing. That's why it is slow. Second reason is it is very complex to code. Okay, even very simple transformations like group by and all, it takes a lot of code to process, which makes very complex to code. Third reason is it is not good for loops. Okay, so in many machine learning algorithms, we will need to loop our large data sets. Okay, and if map reduces speed is low, then it will take a lot of time for it to process. So it is not at all good for iterative tasks or loops. Fourth reason is real time streaming is not supported in Hadoop MapReduce, okay, which is very crucial in today's world because let's say we want to monitor real time data in our Power BI dashboard, okay, so we won't be able to do that in Hadoop MapReduce. Hadoop MapReduce only supports batch data processing. Means we can process the data in chunks. Like we can schedule it in some hours or some days. Okay. So it can only process the data in chunks or batch. It does not support real-time data processing. So these are the four reasons why we are not using Hadoop MapReduce nowadays. Okay. So Spider-Man is asking again, brother, you have mentioned all those issues and all with Hadoop MapReduce. But tell me what is the solution on that? What should I use then? The answer is Apache Spark. Okay. It's a big data processing framework which is solving all the issues which are present in Hadoop MapReduce. Okay, so Apache Spark is a big data processing framework. Now we will see the features of Spark. So Spider-Man is saying, if you were saying that Hadoop MapReduce was slow, it was processing data in disks, then how is Apache Spark fast? The answer is Spark processes the data in memory. Okay, Spark has in memory data processing, which is RAM. That's why it is faster. So first feature is speed. Now you were saying that in Hadoop MapReduce, the programming was very complex, even for simple transformations. Then how is the Spark easy? Because we can write Spark job in Java, Scala, Python, or even the simple SQL. Okay, so programming is very easy in Apache Spark as compared to Hadoop MapReduce. So second feature is easy programming. Now we all know that Hadoop MapReduce was supporting only batch data processing and not real-time data processing, which is again solved in Apache Spark. Apache Spark supports real-time data processing as well. I have written three, but it is fourth. So fourth feature is scalability. So we all know that Apache Spark processes the data on cluster. Okay. So parallel processing is getting performed here in multiple nodes. Okay. Tasks are getting executed in multiple nodes simultaneously. So it is scalable and fast. Fourth feature is fault tolerant. So let's say because of some issue my data is lost. So can I automatically recover that lost data? Answer is yes. In Apache Spark, you will automatically get your lost data. It is fault tolerant. Okay. If any of the node failed, data is lost, then that lost data will be automatically recovered in Apache Spark. It is fault tolerant. Now next is Spark ecosystem. Okay, ecosystem is nothing but a module or libraries which are available in Apache Spark framework. So first library and the most important library is Spark Core. Okay, so it involves RDD, fault tolerance feature is involved in Spark Core. Okay, so memory management is also done in Spark Core and job scheduling as well. So these are the features which we can use using Spark Core library. Second library is Spark SQL. Okay, so we can basically handle our data frames using SQL like syntax. Okay, so we can work with structured data using SQL like syntax. This is the library for that. And Spark streaming means this is the library responsible for processing real-time data. Fourth one is machine learning library MLLeap. So it is used for machine learning. Fifth one is GraphX. Okay, so graph data processing we can perform using this library. Last one is Spark R or Pandas API. So basically we can process the big data using pandas like syntax or using R language. Okay, so R is the another programming language and we can also use pandas API like syntax. So this is the last library Spark R. Now what is RDD? Resilient distributed data set. So first I will tell you meaning of each word involved in RDD. So resilient means fault tolerant. We have already seen that lost data can be recovered. Distributed means the data is processed in cluster parallelly, and data set means it is just a data frame. Okay, so let's see what is RDD. Let's say we have a big data set. So Apache Spark will split this big data set into smaller partitions or smaller parts. Okay, then these smaller parts will be automatically stored in different nodes. Okay, partitions will be stored in different nodes. So together they form an RDD. Okay, so together as a whole, this is known as RDD. Now tell me what are the properties of RDD. So Spider-Man is asking, bro, I have one RDD, I have created one RDD, but there are some issues, so I want some modifications in that RDD. So can you please help me? The answer is no. We cannot modify RDD, it is immutable. Okay, once created we cannot modify it. You will have to create new RDD. Okay, so our first property is immutable. Now Spider-Man is asking, bro, are you sure that RDD is fast? Yeah, answer is it is distributed. So data is spread across multiple nodes. So processing is done parallelly. So I am sure definitely it is fast. Now Spider-Man is saying, bro, my data is lost because of some error. Can you please bring it back? So the answer is yeah, it is fault tolerant. We can definitely bring it back. Lost data will be recovered automatically. Third property is fault tolerant. Now fourth property is lazy evaluation. So Spider-Man is saying, bro, I have written some transformations like map, filter, group by, okay. Couple of transformation and steps I have written. So does Spark process it immediately or it waits for my final order? So answer is it will wait for your final order. It will build the plan. Okay, it will build the plan for your transformation steps, but it will not execute that plan until you give him an action. Okay, so action means final order. In Spark, Apache Spark analogy, it is known as action. You will see it in the future when we will create real world projects. Okay, so yeah, it will wait for your final order, which is action. Okay, so our fourth property is lazy evaluation. This process as a whole known as lazy evaluation. Next is partitioning in Spark RDD. So imagine, check the diagram, okay? So imagine you have a data with 10 crore rows, okay? That is 100 million rows. That is big data, right? Now you want to process that data. So Apache Spark cannot process that data all at once on a single machine. Okay, what it will do then? Apache Spark will check the right hand side. Apache Spark will split the data in small pieces. That is known as partitioning in Spark RDD. Now, these partitions will be processed by Apache Spark cluster. Okay, on different machines, each partition will be handled. Different machines or different nodes. Okay, so each node will handle some partition, and that data will be processed in parallel. But we cannot process it all at once. Without partitioning, we cannot process that big data. Okay, so partitioning is very compulsory process in Spark RDD. Now what is transformations? Okay, to check the diagram, you have some existing data frame. Now on this existing data frame, you are doing some operations, and that data frame is converted into new data frame because of those operations. Okay, so that operation that creates new data frame from existing data frame is transformation. Okay, operation that creates new data frame from existing data frame is transformation. Now what are the types of transformations? So basically there are two types of transformations. Let's first check the diagram. Okay, so Spider-Man is again asking us some question. So he's saying, bro, I tried some transformations in partitions, but after performing transformation, some data is moving in another partition and some data is staying in the same partition. So what is exactly that? And it is even correct or not? So solution is, yeah, it is completely fine. These are actually two types of transformations. We'll check the diagram. So see inside these partitions, this circle means data. So in the left hand side, you see this after performing transformation, data is staying in the same partition. Okay. After transformation, data is staying in same partition. That is narrow transformation. Check the right hand side. In Y transformation, that data is shuffling in another partition. Okay. After transformation, data is moving into another partition. That is Y transformation. Because we are shuffling the whole partitions. Okay. They are not staying in the same partition. We need to shuffle the whole partitions. So when the data stays in same partition, that is narrow transformation. When data moves to different partition, that is wide transformation. Okay, let's quickly check the definition. So in narrow transformation, no shuffle is required, so that is fast. In wide transformation, shuffle, all the partitions will be shuffled. Okay, data will be shuffled in all the partitions, that's why it is slower. Okay, this is wide and narrow transformations. Now what is actions? So check the diagram. We in the left hand side in red color we have set of transformations. Okay, we have written all the transformation which is required for our data, but Spark will not run it automatically. Okay, Spark will need some operation, then only that transformation will be triggered. Okay, so that operation is known as actions. After that action, Spark will run your transformation. So example, whenever you write some program in VS Code or any other IDE, you need to click on the run button, right? Then only that program gets executed. So same way, this set of transformations will not run until we write actions. After writing actions, it will trigger those transformations and Spark will run those transformations. So what is the definition? Operation that triggers the Spark to run transformations. This is actions. Next is DAG. So DAG is nothing but a flowchart, and that flowchart will show all the sequence of operations that the Spark is going to perform on your data. Okay, we all know that Spark will process our data, but what all operations Spark will perform, that also we can check using DAG. It will show all the sequence of operations. Next is Spark job lifecycle. So Spider-Man is asking, I know that after creating actions that will trigger Spark transformations, right? But the question is what after that? Okay, I have created actions, transformations are triggered, but what happens after that? That I need to know. Okay, so the solution is, check the diagram. I will zoom. So first, Spark job will be created. Okay, after triggering transformation, the first step will be Spark jobs. Job will be created in the background. After that, that Spark job is converted into many stages. Okay, Spark will split that task into many stages. Then third step will be, again that stage will be further converted into multiple tasks. Okay, each and every stage will be converted into tasks. So that is the third stage, and yeah, that's it. After that, this task will be assigned to different nodes or different computers, and that will get executed. We will get the result after that. Okay, so I will repeat one more time. Whenever we create an action, Spark transformation will be triggered. But what happens after that? So first is Spark job is created. Second is that job will be converted into multiple stages. Third is each and every stage will be converted into tasks. Okay, stage will be split into tasks. Then that task will be assigned to clusters and we will get the result. Next is, what if the data is greater than cluster capacity? So first let's understand what is cluster capacity. So cluster capacity means how much data Spark can process in memory plus in disk. We all know that by default it will process the data in RAM, which is in memory. But after that it will process in disk. Okay, so that is the complete cluster capacity. It cannot process after that. So now Spider-Man is asking, let's say I have limited cluster capacity, but data is increasing a lot. Then what will happen? Will I get into trouble? Also tell me the solution. So check the second diagram. We all know that. Let's say we have big data. That data as a whole will not be assigned to any node. Okay. Spark cluster cannot process data as a whole. That data will be converted into smaller chunks and then those smaller chunks will be assigned to different nodes. Okay, we all know that. Now next, let's say data is getting full. Okay, it is increasing a lot. So first, by default, Spark will use in memory, which is RAM. But let's say RAM is also full. Then Spark also has plan B. That plan B is disk. Okay. After RAM, Spark has plan B, which is disk memory. It will use disk memory. But we know that we have already studied in Hadoop that disk memory is slower. Okay. Spark uses RAM, that's why it is faster. But data is increased a lot, so it will use disk. Now let's say that disk memory is also full. Then Spark doesn't have any Polish solution. It will directly throw error. Okay. Check the second diagram. It will show out of memory or disk full errors. Okay. I will repeat one more times. First Spark cluster will use RAM memory. If that RAM memory is full, it will use disk memory. If that disk memory is also full, then Spark will throw error. Out of memory or disk full errors. Now Spider-Man is asking, then what is the solution? There are multiple solutions. First solution is increase the cluster capacity. Okay, it will add more nodes and data will be processed. Okay, if data is increasing a lot, then first increase cluster capacity. Then again some optimization techniques you can use, like second is filter before processing. Okay, so before filtering data will be huge, but let's say you can filter the required data, then you can decrease the size of the data a little bit. Third will be use proper file formats. Okay, use efficient file formats like Parquet or ORC, which will compress your data a little bit. Okay, that is the third optimization technique. Fourth will be do not persist unnecessary cache data. Okay, you should avoid unnecessary cache, otherwise it will take your memory in cluster Spark. Okay, so to free some space, you should avoid unnecessary cache. So these are the four optimization techniques which you can use if your data is increased a lot and Spark cannot process it. It is throwing this error. Okay, out of memory disk full errors. Then you should use these four techniques. You can increase the cluster capacity. You can filter your data. You can use file formats for data compression, and you can avoid unnecessary cache. Okay. So I hope you like this tutorial.